Okay, good afternoon, everyone. In today's class, I want to discuss heat transfer by conduction. Now, before I go to that, which aspect of heat transfer by conduction? That is the thermal conductivity. So before I define thermal conductivity or go into details of this, I would like to define conduction. What is conduction? Conduction is the transfer of heat through a solid material without the movement of the particles themselves, or that is the movement of the particles of the medium. So that is what is called conduction. The heat is transferred from one material to another material, or heat can also be transferred at the same material, just like from a hot aspect part of the material to the cold end of the material. So that is what is called conduction. Now let's see thermal conductivity. What is thermal conductivity? Thermal conductivity is the measure of how well a material conducts heat. So materials conduct heat at different rates. For instance, you have metals. You have the silver, the copper, the aluminum, the steel, and so on. All these things are metals and they all conduct heat. But the rate at which they allow heat to pass through them differs, or the rate at which they conduct heat differs. And that's what we talk about, what? Thermal conductivity. We also have poor conductors, such like you have the wood, you also have the air, and so on. All those ones are poor conductors, and the rate at which they conduct heat also differs. Now, one thing, what makes metals to conduct heat is because the metals have a free electron. So when heat is applied, these free electrons will acquire energy, and that means they'll become energetic and move from the hot part of the metals to the other part of the metal. So in that case, but these poor conductors, they don't have a free electron, they just vibrate within themselves. So that's why the transfer of heat in poor conductors are very, very slow compared to that of metals. Now, thermal conductivity, as we said, is the measure of how well a material conducts heat. The rate of conduction, that is the Q over T, is the rate of conduction. The quantity of heat in time T is proportional to the cross-sectional area of the material and the temperature gradient. So this term inside the bracket is called temperature gradient. Now we can say, remove the proportionality, you introduce a constant. So I can have this over this is equal to K into I can have Ka into Th minus Tc over L. Th is the temperature at the hot end of the material. This is the temperature at the cooler end of the material. So we can now say this is the rate of transfer of heat. This rate of transfer of heat, I can call it H. So I can say, let this term here be H. Sometimes this rate of transfer of heat is also called thermal current. We can now say H is equal to Ka into Th minus Tc over what? L. I want to make K the subject of the formula. K will give me, I'm going to have HL over, I can have A into Th minus Tc. This is the formula for thermal conductivity. This K here represents thermal conductivity. You know, the thermal conductivity of materials differs. For instance, how do you know that after solving this calculation, maybe you have the heat current is given, the length of the material is given, the cross-sectional area of the material is given, and the rise in temperature of the material is also given. How do you, if the value you get is, maybe you have a value of 20, you have a value less than 20, and so on. How do you know whether the material is a good conductor or a poor conductor? If the value of K is greater than 50, if you solve this calculation and you have K greater than 50, that material is a good conductor of heat. Now, after solving this material, you have the value of K. K ranges from 1 to 50, meaning that k is greater than 1, but is less than what? 50. If you solve and you have the value of k greater than 1, but less than 50, that material is called a moderate conductor. A moderate conductor, okay? But if you have the value of k less than 1, for instance, you have 0.2, 0.05, and so on, that material is called a poor conductor. So this one we say is a good conductor of heat. Materials whereby the thermal conductivity of the material is greater than 50, that material is said to be what? A good conductor of heat. If you have the thermal conductivity of a material greater than 1 but less than what? 50, that material is said to be a moderate conductor. If you have a thermal conductivity less than 1, that material is said to be a poor conductor. You know, what is these moderate conductors? Moderate conductors, that is in this range. These moderate conductors, you talk about the stone, the bricks, you have the ceramics. All those ones, we call them the moderate conductors. You know, you have the copper, aluminum, and so on and so forth. The metals here are called the what? We call them the good conductors of heat. So this what we are going to employ this equation into calculation, and that is the next class. So please watch the next class and you will get the full details on how to employ these equations. Thank you. Subscribe to my YouTube channel at Easy Physics with Vincent. Follow me on my Facebook page, TikTok at Easy Physics with Vincent. Thank you.